some red lava right there. There's some lava. That's something, that's something. I went to Kauai expecting the waterfalls over there to be spectacular. It's much more beautiful over here, I think. The airplane, we're on Saddleback Road, halfway between the town of Hilo and the town of Kona, looking south towards Mauna Loa. We've been driving for about the last half hour, and it's just miles and miles and miles and miles of lava fields flowing across the roads. Looks like they were coming from Mauna Loa, which last erupted in 1984. You can see where the dividing line is between Mauna Loa. Mauna Loa is 13,700 feet. It's supposedly the biggest land mass mountain in the world. Turning through the east here, you can see where the dividing line is between Mauna Kea and Mauna Loa. Mauna Kea is covered by clouds right now. That's 13,760 feet, just a little taller, but not as massive as Mauna Loa is. You can see where the lava flow stopped. Mauna Kea is a much older volcano. It's not active. Hasn't exploded for hundreds of years. The Hawaiian Islands are located in the middle of the Pacific tectonic plate. Picture a big plate under the Pacific Ocean which is sliding around. This plate slides to the northwest, and all the lava, magma, the molten lava, magma that created the Hawaiian Islands is stationary under the tectonic plate, under the Pacific plate. So as the plate moves over, the plate is slowly drifting an inch a year, I believe the rate is, an inch a year to the northwest, and different holes in the plate pass over this stationary magma. It's stationary relative to the Earth, you know, the poles, I would guess you would say, where north and south are. And as different holes in the Pacific plate pass over it, lava comes up. So that's why the islands in the north, like Kauai, is the oldest volcanic island in the chain and has a lot of erosion on it. Mauna Kea, which is north of Mauna Loa, hasn't been exploding for a long time because right now Mauna Loa and Kilauea to our south are over the hole in the Pacific plate where the magma's coming up. And there's more than one hole, of course, but there's obviously one big one that created all of these islands. Apparently 70 miles off to the southeast of the Big Island, there's another island that's been forming for years and years and years, and it's 15,000 feet deep out there, and this thing's only 3,000 feet from the surface and building all the time. It's erupting as we speak, and soon is probably in a period of dozens of years, there will be a new Hawaiian island. Right now, Hawaii is the newest Hawaiian island there is, though.
Probably have an overweighted load.
It's all right. We'll get it on somehow. Seems to be one of the tour helicopters. Hope it's not the rental car police. We're not supposed to have a rental car up here.
Okay, we're going to drive down the road a little bit and we'll see what happens. Nice and slow like. Hopefully we'll pick up bunch of this lava just as far as you can see. And Brian's another Elizabeth. He's got the whole road and he's driving on the edge picking up all the bumps. There, he must have heard me. He straightened the damn thing out.
Tell him this is
This is volcanic lava flow. You're going too fast, Brian. What the hell's the matter with you? I'm standing on the top of the car right now, folks, trying to picturesque this for you. And we'll pan a little bit, if you call it panning. And there you are, the road dead ahead of us. And just as far as you can see, one way or the other, it's amazing how much rock has been displaced here. Lava flow, what have you, which is caused when the shelves.
There you go. Go with it, go with it.
At the, near the magna in the earth meet, and they rub one over the other.
When two plates rub over each other,
right,
it makes a hot spot,
there's a
melts
friction,
the land.
And it creates a hot molten deposit of rock called magna, and then it disperses the gases with great pressure, and like you up, Chuck, it blows this junk out of the middle of the earth, and there you have a volcano with gases, with heavy metals. There's a lot of metal in this lava flow. Magnesium, aluminum, iron.
Hold on and I'll read the specs, I'll stop.
Okay, we will give you a breakdown on that. Look at that, folks, right dead ahead. Just as far as you can see, mile after mile after mile. And we are going to give you a breakdown as to the particulates in this lava flow. Just as far back as you want to see the road that we have covered. Isn't that amazing? Magnificent to watch. I think we were up there a little while ago in an airplane. And just yesterday, we were up there walking around at the crest of the crater. Fascinating. Last night we were have a little description here of the mineral deposits of the lava.
Here's the chemical breakdown. I'll give you first the Hawaiian volcano breakdown for lava, and then the Mount St. Helens for a comparison. Silicon is the largest constituent. 48% in Hawaiian volcanoes is silicon, 64% in Mount St. Helens. Aluminum, 13% Hawaii, 18% Mount St. Helens. Iron, 11 and 4. Magnesium, 10 for Hawaiian, 2 for St. Helens. Calcium, 10 for Hawaiian, 5 for St. Helens. Sodium, 2.4 Hawaiian, 4.6 Mount St. Helens. Potassium, 0.6 Hawaiian, 1.3 Mount St. Helens. Titanium, 3% Hawaiian, 0.6% St. Helens. Other metals, 1.4 Hawaiian, 1.0 Mount St. Helens. And that's one reason the Mount St. Helens was so much more destructive, from what I understand, is the composition, where you have much more silicon in the Mount St. Helens lava, makes it much more viscous, which makes the pressures build up to much greater values.
That means that the lava was lighter and it flowed easier.
In the Hawaiian. But much more viscous for Mount St. Helens, and the pressure built up, hence half the mountain blown apart.
Viscosity meaning that it is the density of the material. The more viscosity, the denser it is.
The temperature of this lava is about 21 or 2200 degrees Fahrenheit when it's coming out.
that will melt steel, and it will certainly melt glass. And by the way, while we're on this subject, it's the end of the tape.